This lesson is on finding the side of a triangle. When we talk about the introduction of trigonometry, we are going to be focusing on right triangles. And of course, what makes a right triangle is a 90-degree angle. So that 90-degree angle is everything, because we are going to be looking at that 90-degree angle, the right triangle, as the basis of today's lesson and, in fact, the rest of this unit. So all the trigonometry that we're going to do in this course is going to be centered around right angle triangles. In a right angle triangle, there are three sides. The three sides are the hypotenuse, which is always the biggest side of the triangle. And then there's also the adjacent and the opposite. And the adjacent and the opposite are dependent on what angle we know, and specifically the location of that angle. So what do I mean by that? Here's the angle that we know. Directly across from the angle that we know is the opposite. The opposite is always across from the angle that we know. So therefore, the last side of the triangle is the adjacent. Now let's talk about that angle that we know for just a second. That angle that we know has a little bit of a funny symbol beside it. The symbol looks like this. It's a circle with a horizontal line through it. That circle with the horizontal line through it is called theta. Theta is one of the letters in the Greek alphabet. If you've ever heard of alpha, beta, omega, gamma, phi, those are some of the other letters in the Greek alphabet. Theta is used to represent an unknown angle. Not all the time in math, but a good amount of time in math. When you do a question from a textbook or you look at a question online or something like that, they may have a theta beside an unknown angle. And so it's just like an X or a Y or a P or a Q. It's a variable, but it's a variable that we typically see to represent an unknown angle. Okay? Now, here's another important thing. When you do this kind of stuff, you need to make sure your calculator is in degree mode before we get going on the stuff, okay? Now, you can use the calculator on your smartphone. You can use a scientific calculator. You can use a fancy calculator. It doesn't matter. But either way, you need to make sure the calculator is in degree mode. We are going to go through a few calculations, and if you do them with me and you get the same numbers that I do, then you're going to be sure that your calculator is in degree mode as we go along. Now, before we get to that, though, I want to go over the three formulas. Now, these three formulas are the backbone of right triangle trigonometry. And here they are right here. So let's go over the first of the three formulas. The first of the three formulas is for sin theta. Now, it's not actually sin. Sin is a short form for sine. So we actually pronounce it sine, the sine of theta. Now, the sine of theta is a ratio between the opposite side and the hypotenuse side. So if you want to find the sine of an angle theta, you always divide the side opposite away from it by the hypotenuse. and the hypotenuse is the biggest side in the triangle. So for that reason, the sine of theta will always be below 1. It'll always be below 1. It could equal 1. I should clarify that. It's going to be 1 or less. It's never going to be over 1. Okay? Now, then we have cos theta. Now, it's not actually cos because just like sin was the short form for sine, cos is the short form for cosine. This is the cosine of theta, and the cosine of theta is a ratio between the adjacent side and the hypotenuse side. And again, since the hypotenuse is the biggest side, the largest the cosine could ever be is 1. It'll be 1 or less. Okay? Then last but not least, we have the tan. Now, tan is the short form for the tangent. So the tangent of theta is opposite over adjacent. Opposite over adjacent. Now, opposite over adjacent can be less than 1. It can be 1. And unlike the other two ratios, the sine and the cosine, tangent can be greater than 1 as well. So it could be anything. Okay? That's good to know. Now, instead of trying to struggle to try and remember all three of these formulas, there's a catchy little expression that's going to help us. And that catchy little expression is SOHCAHTOA. Now, SOHCAHTOA, if you remember it, is going to take into effect the fact that sine is opposite over the hypotenuse. That's the SO part. Cosine is adjacent over the hypotenuse. That's the CA part. And tangent is opposite over adjacent. That's the TOA part. So if you remember SOHCAHTOA, you will remember those three formulas. So just say it a few times and remember those formulas, you will. Now we are going to test out our calculators to figure out the sine, cosine, and tangent of a few different angles. Before we do that, just an important note here. We tend to use 4 decimal places, and the reason for that is to ensure accuracy. So lots of times in math, we'll use 1 or 2 decimal places, but when we find the sine, cosine, or tangent of an angle, we are going to buck that trend a little bit, and we're going to write our answers to 4 decimal places. And we will need to round the 4th decimal place appropriately, depending on what the 5th decimal place is. So let's go ahead and figure out some of these things. Now, if you have a normal scientific calculator or you're using your smartphone, chances are what you are going to be doing is you are going to be entering the 54 first and then finding the sine button and pressing it. Now, some calculators, you will actually type in sine first and then the 54. When you do it, this is what you should get. You should get 0.8090. If you got that, great. If you didn't, well, take a step back, try to go ahead and enter 54 first maybe, then sine, and make sure you get 0.8090. Also, just another reminder, your calculator does need to be in degree mode. There's also a radian mode. That's not going to be helpful for us in this class. Next up, we go to the cosine of 20. So cosine of 20 is going to be 0.9397. The 6 gets bumped up to a 7 because the 5th decimal place is a 9. And last but not least, the tan or tangent of 60 degrees, and we get 1.7321. That's the tangent of 60 degrees. So if you're able to get the same numbers that I got, then that means that your calculator is set to degree mode, and it also means that you know how to use your calculator to evaluate these trigonometric functions. And now we're ready to go ahead and find some sides of triangles. So now let's find the value of x to the nearest tenth. So we're going to focus in on this first question. So the very first step of doing this question is we are going to label the sides. In this question, there are two sides that we're interested in. The side that we know, 15 centimeters, and the side that we are trying to find. So the side that we know is across from the 90-degree angle, so this is the hypotenuse. It is the largest side of the triangle. Now, what is the x? The x is opposite to 28 degrees, so it is the opposite. So in this question, we're dealing with the opposite and the hypotenuse. And so what we need to do is we need to remember SOHCAHTOA, because SOHCAHTOA will tell us whether we are using the sine, the cosine, or the tangent. So we have the opposite and the hypotenuse. So we have sine, which is opposite and hypotenuse. Ding, 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 we got a winner. It's a sine. Cosine and tangent don't deal with the opposite and the hypotenuse. So it's got to be sine. So the sine of 28 degrees, the given angle, is equal to opposite over hypotenuse. Now we're going to take our calculators and we're going to figure out sine of 28. 4 decimal places, it's 0 decimal. 4,695. The opposite is our x. The hypotenuse is our 15. And we are going to drop a 1 below the decimal. And then what we're going to do is cross multiply. And if we cross multiply, we get 1 times x, which is x, and 15 times 0.4695. And when we do that, we get 7.0425, which if we round to 1 decimal place is 7.0. And we have to put the 0 because it's not exactly 7. And the units in this question are in centimeters, so we need to include our units and we'll put centimeters. So x is 7 centimeters. Okay, so that's how we do a question like this. So just a quick recap before we move on to the next one. The first step is we labeled our sides. Then, after we labeled our sides, we determined whether we would be using sine, cosine, or tangent using SOHCAHTOA. And then we wrote out the expression and we solved for our x using our equation solving techniques that we learned in grade 9. Now, let's try another question. Here's our next question. So again, first step, label the sides. So across from the 9 degrees, that's the known angle, 11 centimeters is going to be the opposite. And x is not across from the 90-degree angle, so it can't be the hypotenuse. So by process of elimination, it's got to be the adjacent. So in this question, we are dealing with the opposite and the adjacent. So using SOHCAHTOA, we will figure out that in this question, we are going to be using tangent, because tangent is the TOA part, opposite and the adjacent. So it's going to be the tan of 9 degrees equals opposite over adjacent. So the tan of 9 degrees is 0.1584. The opposite is 11, and the adjacent is our x. And we can go ahead and drop a 1, so it's just easy to do the cross multiplying. Now we're going to get 0.1584x equals 11. And in order for us to figure out x in this question, we are going to have to take 11 and divide it by 0.1584. So 11 divided by 0.1584, and we get x equals 69.4, and the units are centimeters, and that's it. And for a question like this too, or any question, but especially a question like this, use the does this make sense thought process. Because if we get an answer of 69.4, that's 69.4, which is way more than 11. If we got an answer, for example, that was less than 11, like say 2.5 or something goofy like that, well, that wouldn't make sense because the picture we see shows that side X is way bigger than 11 centimeters. Now, not all math pictures and questions are to scale, but still we can use it as a guide to help move along our learning and our ideas, okay? So 69.4 centimeters is the length of side X. Now we're going to move on and do another couple examples. Here's the next one. Same idea. Where's our sides? Let's label them. So X in this case is across from the 90-degree angle. It is the hypotenuse. And 12 meters, the other side in this triangle, is not across from the known angle, so it's not the opposite. So it's got to be the adjacent. So in this question, we are using the adjacent and the hypotenuse. So using SOHCAHTOA, in this case, we're doing ka. So it's going to be cosine. Cosine of 32 degrees is equal to the adjacent over the hypotenuse. So cosine of 32 degrees is 0.8481. The adjacent is 12. The hypotenuse is x. Let's drop a 1 underneath. And then we're going to go ahead and cross multiply. So we're going to get 0.8481x equals 12. X equals 12 divided by 0.8481. Oopsies, no x. And now just go ahead and complete that dividing. 12 divided by 0.8481, and we get 14.1 meters. Make sure to include those units, and that's the answer that represents the side X, otherwise known as the hypotenuse of the triangle. And again, if it's the hypotenuse, it's the biggest side, and it's bigger than the other side we know, so that makes sense. We're going to do a bit of a word problem here, and that will wrap up today's lesson. So, in a right triangle, the leg opposite a 35-degree angle is 12.1 meters. Find the length of the hypotenuse to the nearest tenth of a meter. So it gives us information and we need to draw out a triangle. So here's a right triangle. It doesn't have to be to scale. There's a 90-degree angle. It says the leg, that just means side, opposite a 35-degree angle. Let's say that's 35. So we're going to go across from there, and we get a side of 12.1 meters. And it asks us to find the length of the hypotenuse. So let's call that x, and we're off and running. So what do we have here as far as what's our sides? Do we know the opposite? Do we know the adjacent? Do we know the hypotenuse? Well, we already know that the 12.1 is across from 35, so that's got to be the opposite. And we already know we're looking for the hypotenuse, so guess what? That's the hypotenuse. So in the SOHCAHTOA, in this case, it's SO. So the sine of 35 degrees is equal to the opposite over the hypotenuse. Sine 35 is 0.5736 to 4 decimal places. The opposite is 12.1. The hypotenuse is x. We'll drop an invisible 1 underneath. And then we'll go ahead and do that cross multiplication stuff. So we get 0.5736 times x equals 12.1. So to figure out what x is, we're going to take 12.1 and divide it by 0.5736. And when we do that, we get 21.1 meters. That's our answer. So that is the length of the hypotenuse in the triangle.